Okay, in this video we're going to take a look at 6 examples of solving literal equations. The first 3 for y, the second 3 we're going to solve for x. And so we end up with, we begin with 3y minus x equals 9. And recall that we're solving for y here. So the first thing we're going to do to isolate the y, add x on both sides, and we get 3y is equal to, we cannot add the 9 and the x together, they're not like terms, so 3y is equal to 9 plus x, dividing both sides by 3, we get y is equal to 9 plus x over 3. This can be split up, so we could write this as 9 over 3, which is 3, plus 1/3 x. So either of those ways, or something in between those, should be fine. Alright, so that takes care of the first example. Second example, again, we are solving for y. So we start with 2x minus 2y equals 5. We want to get rid of everything that's not y. Leave the y alone. Don't touch it. Sorry, we're not going to add. We're going to subtract 2x on both sides. Remember that the left side is just negative 2y. The right side we can't combine 5 and minus 2x or negative 2x, so all we can say is 5 minus 2x. At that point, can divide both sides by negative 2, and we would end up with y is equal to 5 minus 2x divided by negative 2. Now this can be split up. It gets a little bit complicated, so if you're in the habit or if you like to split those up, be careful. You have 5 divided by negative 2, which is negative 5 halves. Then you have negative 2x divided by 2, which is simply a positive x. So if you're going to split up, then remember that there are some complications involved in that, and you have to watch your signs very, very carefully. But as I said, splitting up those terms there is actually good. It's going to lead to something later on. I don't require it at this point, but if you want to do that, you're more than welcome to go ahead with that. Alright, so the final example on this page, 20 is equal to 8x plus 4y. Remember again that we're trying to isolate the y. So I'd begin with subtracting an 8x, subtracting an 8x on both sides. I can't combine 20 and negative 8x, so I leave them as they are. And I get 4y on the right. I can divide both sides by 4. And so if I turn this around, y is equal to 20 minus 8x over 4. That's sufficient for what we're doing right now, but some people might notice that, hey, if we split this up, we can get something like 20 over 4 is 5, and then negative minus 8 over 4 is 2, so this is just going to give me a 2x, which looks a lot nicer than that fraction. So I'm okay with taking that extra step, assuming that you don't make a mistake. If you take the extra step and you make a mistake, then you're technically wrong there. All right. So let's go on to the next set of examples where we will solve for x. Okay, then these examples are very similar to others, but they have some different points to them as well. All right. So we want to solve for x. Well, if you look at the first equation, we have y is equal to 5x minus 4x. And you might think that you need to do that factoring process. Actually, there's nothing wrong with doing the factoring process. You'd bring out an x, and that would simply leave you with 5 minus 4, which you know how to do. 5 minus 4 is 1. So this just leaves you with 5 is equal to x. Now, you could have also just subtracted 5x minus 4x, since those are like terms there, and you would have gotten y equals x at the very beginning. And so there's nothing more that can be simplified. That's pretty straightforward there. In the next example, 2x plus kx is equal to m. Well, here there's nothing that we can do to combine the 2x and the kx. They're not like terms, although we could say that we have 2 plus k x times x. I'm going to factor out the x and get a 2 plus k equal to m. And again, I'm trying to solve for x, so I'm just going to divide both sides by 2 plus k. And that would leave me with x is equal to m over 2 plus k. Now, remember what we said. When you have 2 or more terms in the denominator, it cannot be split up into multiple fractions. Very important point. This is as far as this one can go. Next example. We have 3 plus 5x minus kx is equal to y, and we want to solve this for x. Okay, so solving for x, we can't subtract kx from 5x. We don't know how much k is. However, we can factor out not a k. Do we want to do that? I don't even think we want to do that, so time out. So even though we could factor out a k, we don't really care about the k here. So actually, I'm just going to isolate. My goal is to isolate the x. So everything else can go. I'm going to start by subtracting 3 on both sides. And that would give me 5k minus kx. You know what? I made a big mistake on this one. Time out. I'm going to start this particular problem all over again because there was no k. It was 5x and not 5k. So we did need to factor, and I made a big mistake here. So scratch all of this and we'll start it over again. Okay, sorry about that. So we have 3 plus 5x minus kx is equal to y. So here we actually can factor out an x. And that would look like 3 plus x times the quantity 5 minus k is equal to y. Now we start the process of isolating our x, and we would do that by subtracting 3. And we have x times 5 minus k is equal to y minus 3. At this point, the only step left to isolate the x would be to divide both sides by 5 minus k, and we would end up with x is equal to y minus 3, all divided by 5 minus k. And again, because there's more than one terms in the denominator, we can't split that up, or it's not helpful for us to split it up. And we end up with x equals y minus 3 over 5 minus k. Alright, so we're going to stop this video at this point. I apologize for the mistake on number 6. Make sure that you catch what it was that I did there and how we should go about doing this correctly.